Hello everyone, thanks for coming this late. I am glad to say that officially we already have server to work with. So it means that the whole team of Lightbloom can use this server for run any project, to run any training scripts for evaluation, inference, etc. So I am going to explain a small overview about what is the workflow could navigate into this server, and also which practice we should follow to work during the whole process of all projects. So, for example, if we go to GitHub, Lightbloom already has a repository of the documentation to see how is the process to go into the server. So first of all, this is like the first node of our cluster. It's a GPU 5080 RTX Gunward Phoenix. Pretty good and very expensive also. So, for example, how we should connect to this server. If where is this? It should be here. Yeah. I am already in the server. So, for example, I am going to open another window to explain how it's the SSH connections. So, but before. Here I have like the users of that have access into a server. In this case, Mugi, Eman, Zainab, and myself. So, for example, if let's gonna make a connection using the account of Eman. If I go to another window, I can type, for example, SSH, the user. That in this case is Eman, and we are using two networks. We are using Wi-Fi and also the Ethernet. In this case, I am using the Wi-Fi, so I should connect to the IP of the Wi-Fi. Yes, 50. Okay, so in this case, the system requires the password, and Eman should know what password he has. So if he asks me, of course I will give the password to him. Okay, now we are already into the server. So first of all, we have like these structure folders. We have a folder where we can deposit the whole our datasets, the projects, and also some scratch, like some helpers if we would like to run something else. Okay, so if we check the structure of the server itself, and the users don't have access to go back to their home folders. It means that they cannot go to home. They don't have permission to write or open folders out of their folders, and also the users don't have pseudo actions. It means super user actions. This is just for security measurements. So this is the option to connect to a server from the terminal, but also there is the option to connect to the server using Visual Code. If I open Visual Code, this is like a tutorial video. And if I open, I can connect to the server. But before, I should create a config file. And here, for now, we have to put the IP of the server. In this case, is Now I establish the connection, and Visual Code at some point requires the password as the terminal did. Okay, now I have access to the folder structures. So in this case, I can open all my folders from Visual Code also. That it's more comfortable. Okay. In this opportunity, I already have open projects. So for example, if I go inside of my projects folder, I think I have 3 repositories already created. So in this case, the Gaussian splitting, and also the panel to run, and of course the documentation. So one of the questions could be like how I can, for example, run my projects, or how I can install dependencies, libraries, which environment should I use. Okay, first of all, we should not install anything inside the systems. It means in the main system we should not install nothing. It's enough with the NVIDIA drivers and also the the basic libraries, like for example Git or I don't know, maybe unzip functionalities. So if we go back to the server again, we can see that the drivers of NVIDIA works perfectly. And the whole process are running okay. So the structure of the workspace is, for example, first of all, you should, if you want to pull a project from any repository, you should initialize a Docker file where you can put the main functionalities. Like for example, in this case, for Gaussian project, I create a Docker file for CUDA libraries, and also some libraries that it's required for the repository itself. And for libraries like, for example, OpenCV, NumPy, I can create a YML file. Some repositories already include these kind of libraries, and inside of the container of Docker, I should pull all these libraries using the Conda environment. It sounds complicated, but actually it doesn't. I mean, if you follow the instructions of the repository, so you will not have any problem to could build the project what you need. So first you have to use Docker and you have to use Conda. And the way that you should run this project, it's based in HPC using SLARMs specifically. So if we go back to our project, for example in Gaussian splitting, I already have SHL file. That it means that I establish the whole resources that I will use. Like for example, the GPU, in this case we just have one, and also the reference of our Docker container, and also the reference of our Conda environment. So we should encapsulate the whole procedure to run our scripts inside of a .sh file. Because we are using SLARMs, it means that we are using a key principle to run all our scripts. But for example, and to run this project is pretty easy. I just should like do this sbash, and for example the name of this file that it's Gaussian bash.sh. So here in this case I submitted a job. It's job number 21. If I wanna see the logs of my queues, the command is sq. the number of my user, that it's engineer in this case. So here, for example, I can see that my job, it's currently running without any issue. And also, another question could be where I can check my logs, or where is a place, interactive place, where I can see like the status of my application. If I open the folder logs and I see the last two folders, that in this case is the output file and the error file, I can see that my app has started without any issue. It means that everything is okay. For example, yeah, I don't have any error for the moment. So this is just the introduction part of how I can navigate into the server. Now let's go to the results. I could make some benchmark results here running the Gaussian splitting. I would like to show you. What is it? Oh no, yeah, here. Okay, here, for example, I could renderize the kitchen of our office puzzle in Budapest. Actually, it looks pretty good. So it means that our server works perfectly without any issue. Also, this is an example of plaza in front of the office. Of course, the quality here is not the best because I use, in this case, just 3,000 iterations. But for the kitchen, I use 50,000 iterations, so the quality it's better. And also have the option to open a PLY file here in Blender, where also I can have more interactions. So as you can see, the quality is pretty good. So if also I have a report of our last results, and I am glad to say that here, if I compare the old NVIDIA we used before for the first demo, that it was a RTX 2070. First of all, the time spent is almost more than 2 hours for iterations of 50,000, and the RTX 5080 is almost 20 times faster. The space that the training in this case require is much less, instead of using a 2070. And the temperature of the GPU is much less, like actually almost a half. So in conclusion, we have pretty good results of this benchmark, and also we already have infrastructure to run all our projects. That's it. Thank you so much.
Very cool.